So in this demo, I'll show how we can take the model that we made in the previous demo and turn it into a working robot. So we begin by enabling physics rendering. This will allow us to see the rigid bodies and the colliders for the robot. So the orange box there represents the rigid body, and the green mesh represents the colliders. So as you can see, each wheel has both a rigid body and a collider. So these two properties are what give the robot substance. Their effect will become immediately apparent when I start the simulation. So when I hit play here, you'll see that each of the wheels has dropped and landed on the platform. The chassis has not dropped because I've set it to kinematic. The reason why the wheels dropped is because they have rigid bodies, and the reason why they landed on the platform is because they have colliders. So what I want to do is specify the relationship between each of the wheels and the chassis, and this is done by creating a constraint. A constraint is like a hinge, or a joint. So we're going to be using a hinge constraint for this, and we set the axis to be the axis of the wheel, and we notice that that wheel did not fall. It stayed connected to the chassis in the air. When we disable the chassis as kinematic, we see that it actually does fall, but that the wheel keeps it from falling through the platform. So this effect will be a little bit more noticeable when we enable the second wheel here. So as you can see, both wheels are now holding it up because they both have hinge constraints connecting them to the chassis. And now if we make a third hinge constraint between the Omni wheel and the chassis, when it drops it actually lands pretty nicely this time. That's because it has 3 points of contact, the 3 colliders from each of the wheels. And so when we add the fourth constraint, we've added all of them here, we see that the Tetric spot lands, and we're able to actually drive it around now because I've mapped some controls to each of these. I'll get into that later. And when I pull up on the robot, we see that gravity keeps it down, and actually the robot's done.